loud exactly.
Yeah, everybody has to talk loud. So I just turned on the recording. This is the deep dive session at the API Machinery at KubeCon. I've got a couple topics here. I'm probably just going to come down and sit in the audience because it's kind of weird standing up here at the podium. Yeah, so there's not that many of us. We can all like together, unless you like sitting in the back and listening. So the metadata only. Have you considered, because there's a, so are you using the shared informer or are you using the controller library directly?
I was trying to just use the reflector library. I don't even want to find out when it changes. I query it, I query the cache when I'm interested in getting bot. But 95% of the code involved in setting up the lists and the watch and reacting and error propagation. I don't want to rewrite all that.
So I wonder if you could, because the reflector takes a lister watcher object.
Yeah.
I wonder if you could convert it at that point, because reflector is agnostic about the type.
Well, that's what I tried. It is not as agnostic as I would hope. There are some places where, for instance, it wants you to implement meta.object, or maybe it's v1.
It wants to be like an API object.
Yes, and then there's also like you need to have a list object. So I've
So there should be tools. It shouldn't be too hard to satisfy that interface, and there's already some code that will convert from a list API object to like an array of things.
Yes, there's like the extract list.
Yeah.
So have you looked into the garbage collector, because that does the similar things, because they only want to have object matter as well.
Okay.
And I think they have a special serializer codec, which fills a metadata object. So it's not the real pod, it's a special struct which is defined there.
Okay.
And it's just does a filtering in this codec step.
Oh, okay.
And I guess you add the codec to the scheme probably.
Yeah,
and then you have those objects inside of your cache.
Right. That sounds like what I'm doing. I did get as far as I used that filtering.
Okay.
I can't remember what it is, a filtering watch or something, and then I implemented my own watch interface that tries to do this translation. But you wind up writing 15 methods that do nothing, for this object. Like setting its resource version is apparently critical. If you don't propagate that resource version through the whole.
Yeah, that is going to be important, because that the reflector machinery uses that to figure out where to restart a watch.
Yes, I figured that out. It seems all the objects are internally keyed. So even though the cache is a map from key to object, it all insists that the object always knows its key, which is kind of annoying. You can't lift that out of the object.
Yeah.
But I understand, that the audience for this was all of the API objects. So when you're trying to store less than that in the interest of conserving space, you wind up duplicating.
Yeah. Other options, just to be completely exhaustive. I think the reflector is somewhat agnostic about the cache that it uses. So you might be able to construct a cache that implements the interface that the reflector wants.
Yes, that throws away what it doesn't need. Yeah, that was where I was going to go next.
Yeah, I think monkeying with the scheme that Stefan was saying is probably the most complete, but maybe not the easiest.
You can copy it.
Yeah, you can copy it.
Right. Yeah. Thanks for the tip.
Yeah, as an example, it's probably
Yeah, the garbage collector is a pretty useful example because it watches every object in the system, and it dynamically starts watching new objects.
Okay.
They get added to the API system because our API type systems add stuff that comes up. Cool. Next topic is why are we so user hot?
Yeah, just to add to the dependency header that he outlined here. So that's one of the things I brought in the session as well. So I was working with a client which was using the dependencies to build out a Kubernetes client. It's the Fabricate client. And pretty soon when I wanted to make some changes to it, for example, to bring in roles, role bindings when RBAC was announced, and I found myself in the same dependency here, which I was going for finding the exact Git hashes just to make sure that my group goes through and generates a correct schema for it. So that's one that got me interested into knowing the fundamentals of how this is happening. Like from the API point of view, how do you determine the different packages or separation of concerns? So I was wondering if you can use the response to this question to also motivate the fundamentals of this, because I walked into the session thinking that I may be able to eventually be able to contribute to the API machinery itself. So I would like to get some sort of grounding in it, if that is not deviating from the agenda that you already have in mind for the start.
No, there's not really an agenda here. So, yeah, I think in regards to the libraries that we split out in our publishing, we've made it sort of possible to build stuff, but we definitely haven't made it easy. Thank you. I'm glad to.
No, I mean, like in 1.8, there are, at least when I think it was 1.8.2 when I last went through my last cycle of trying to get this, like there were starting to be tags on repos, and like before it was like you went into the main Kubernetes repo and then you look at like whatever repo and you're like, look at the commit message to see like which should the hash that it came from, and then like all of the actual sub libraries didn't necessarily match. Like at the point at which they were merged back out into the repo wasn't the same, so like they got some
tuning, so they are dropped commits, so you don't see them. So they don't change. It's old, looks old.
Yeah. But then some of the dependencies and stuff were like for like third-party dependencies were different, and you would like get weird behavior.
I want to blame the Go dependency management system for most of this.
Or lack thereof.
Just some hints. So the Go that's JSON in client Go, that's up to date. That's the reference you can always use. Elite uses that as well, so it's also pretty good. Just a warning, dep does not read that file, only on init.
Yeah, dep has a major bug.
So it only works when the master of the dependencies is compatible, which is maybe now today for 1.9, but in 3 months. So if you use dep, you have to specify everything.
I really hope they will fix this.
Yeah. So there are issues open in dep, and Sam Boyer, the main guy, works on that. So they're aware, but at the moment it's stable.
That's the one you filed, right?
Yeah, there are two. One I fired, and there's another one now.
Yeah, you can thank Stefan for the tags matching up.
Yeah. I mean, it made it a lot easier to actually build.
Yeah, I can. Going back towards your question, I can say for myself, we've gotten to the point where it's sort of possible, and I and my team have been focusing on extensibility related things like webbooks, all this other all that sort of stuff. So I haven't been focusing on like in my ideal world, the repositories that we've split out would be properly versioned, and we would do development in those things, and we would suck those back up into the main repository when it's time to make a release or a distribution or something like that.
Is there other plans to like just actually vendor them into, like, I mean, that would seem like the like most sensible way is to have all the independent libraries, and then those should get vendored into Kubernetes.
It's a balance. I mean, our development gets harder by that.
Sure, yeah.
But the experiment is with parties.
It's hard, and specifically it's hard because of like testing and making sure that the final thing still works. And yeah, some people don't expect that you have to make multiple PRs to like you make a PR to fix the library, and you make another PR to vendor it into the main repository, and like when you have libraries importing other libraries, which we do, you can have like 2 or 3 or 4 layers of vendering PRs.
Is that just,
I don't know. I think I don't have too much sympathy for that, because I think practically speaking, you should probably be making multiple PRs anyway. You're fixing stuff like that, but
I mean, it seems also to be the factor of like how new and the velocity of change, and like getting the extension points there such that it can be extended. It would mean that those the underlying libraries, like API Machinery or whatever, would stabilize over a period of time. You wouldn't necessarily
have that many changes going on in the libraries themselves versus.
Yeah, that's Jordan Leggett here. Jordan's not here. Yeah, that's something that we've debated, which is how to what point do we want to lock down the interfaces? Some people call that stability, and some people call it ossification. I hope to get there sometime in maybe 2018. I think the rate of change is hopefully slowing down. I think it's time to start thinking about things like SDKs, not just for clients, but also for server components.
I mean, like the meta controller stuff, I think solves. I didn't actually look too deeply into it yet, but it, for building custom controllers and stuff, it seems like, okay, fine, then I don't ever need to deal with this pain ever again. Yeah, if that actually solves the use case.
Yeah. Other topics? Hi, there's a lot of people in this room. I'm Daniel. I'm one of the co-leads for API Machinery SIG. I'm the TL for the Google team that works on related things. The other co-lead is David Eads from Red Hat, who's not here today, but Jordan from Red Hat is. So say hi. Yeah, yeah.
Another question. Maybe this is now in the documentation. I'm confused by where the threshold lies between what's in the API machinery and what belongs in the client code. And I think I know the answer is that if you might need it when you're writing something that isn't a client, it should probably be an API machinery, either below client go or up above it, stuck in Kubernetes.
Okay, so yeah, you're talking about the API machinery repo versus the client go repo?
Yes.
Yeah, the API machinery repo has to do with the serialization, deserialization stack. So if both server and client need the code, then it should go in API machinery. Only a client would ever use the code, it should go in client.
Okay.
And like some processes act as both clients and servers, and they will need both libraries. But just logically speaking, if you're looking at a single connection path, if you need some library to support both ends of a single connection path, then that library should go in API machinery. Repo.
Okay.
But if it's code that only makes sense on the client side, then it should go in the client repo.
And of course, there shouldn't be references to objects on Kubernetes in API machinery. So no pods or something like that.
That's all now down in API.
Yes, the types are in API, but if there are some helpers, some tools, whatever, they might go to client, but not to.
Yeah, that's something I hope to. So I'm giving a SIG update later today, and I've got a slide on what is API machinery and what is not API machinery, because from the GitHub issues that I see, a lot of people don't understand. So, yeah, I'd be happy to
eventually add some topic there.
yeah. Let's see, do I have it up? I think I have it up. This is on the screen now. This is the slide I've got so far. Maybe you all can help me write this slide.
Sure.
So what does API machinery own in sort of concrete details? Kubernetes is a hub and spoke API system where the API server is sort of the hub and there's many clients, including like functionally speaking, most of the business decisions are made in clients. So we own the API server, which is the center of the hub. We also own the generic API server library, because the API server is sort of a system of federated API servers, so it's growing into that. And we own the storage path, so behind the API server, all the way over to etcd. We don't own the operational aspects of etcd. I will say my team at Google gets involved with some of that in Google, but and so we've got experience, and we try to supply good solutions, and I know our colleagues at Red Hat are in a similar position. But we're not your SRE. if that makes sense. We also own the client generators. So this is like the open API stack, which makes it all possible. The generation stack. There's a Kubernetes client repo with the gen. I've heard chatter about like starting up a client SIG, which maybe we could eventually roll those over onto. And if that happened, I think we would still own the generation of the open API stack. But for now, I think our SIG basically owns the client generators also.
When you say client generators, you're talking about everything that's in like, not everything, but a lot of what's in the like hack directories.
There's two main things I have in mind. Yes, we do own some of the things in the hack directory. There's two main things I have in mind. One is there's some tooling around feeding. Actually, maybe some. Yeah. So there's some tooling around feeding the open API stack into the Swagger generator program. So we own that. Actually, many wrote basically all of that, right? And we also own the Go client has its own special generator. We own that.
The Informer generator as well.
Yeah, and the Informer generator, but that's not. I guess that's kind of a client thing. Yeah.
Most of the code generator, but not formally, but in practice, yes.
Yeah, I think most actually a mini rant for me. Like I think almost all of the code generation is a Go language bug report. The generation I think is fine is the serialization code that turns like Go structs into a wire format. Like I think that's a reasonable case for code generation. But the Informer gen, the Go client gen, like wouldn't that be so much nicer with generics?
Sure.
And like the deep copy gen, like most of the reason that we have that is that Go doesn't have a constant keyword. So yeah. So going, we already talked about the serialization stack. So the converters, the defaulters, the wire format, which is both JSON and proto, and a kind of a particular proto format. And I'll go thank Clayton for that. Our proto format, if you don't know, it's an envelope, which is different from how most proto stacks do it. But the envelope tells the type and the encoding. So there's like a header and then like just a stream of bytes, and the header tells you what object type is in that stream and how it's encoded. So you can actually stuff JSON in the proto, or you can stuff it, or you can encrypt it, or you could compress it. Yeah, unfortunately, that makes interoperability with gRPC clients challenging. Yeah, so we own the controller framework code. I think we also own the garbage collector and probably the namespace. Sorry, not collector. The namespace controller. Why? Yeah, because namespaces. This is sort of hypothetical on my part. I don't know. Stefan, what do you think?
I think the types are in Kubernetes officially for V1.
Yeah, I think maybe.
But all the logic that you can have a namespace in the HTTP path, that's core. It's economically good. So.
Yeah, I would argue if you own names, you own namespaces.
So the reason why I think namespaces is under our jurisdiction is there's no one else that it would fall under. And multiple people have in the last couple of weeks have floated this idea by me. If we were to separate out the API serving stack from Kubernetes, like people would come to me like, I want to do Kubernetes style APIs without a Kubernetes cluster. And if you look at what does it take to provide the Kubernetes API style, you need the garbage collector and you need namespaces, because like if you want to just run CRDs, for example, they're namespace. You need the namespace controller to like start up and shut down those. So I think the namespace controller is actually part of the general API machinery tooling that we have.
There was an idea to have the Kube API server into the heart of Kubernetes or the base stuff that more or less what you were saying.
Yeah, I've been suggesting to people, if you want to experiment with that, just run a stock Kubernetes API server and use the runtime config flag to turn off all the APIs that you don't want to use. I think it should work. I haven't tried it. which should be pretty cool. Let's see, what else do we own? We own the API style guide, the patterns like spec and status. We own our mishmash of an IDL that the API types are defined in, Go structs. We own linters. We often own linters. They don't exist yet, but they're coming very soon. Yeah, object conversion control mechanisms. And I have, oh yeah, and that adds up to about 25% of the Kubernetes code base. Some, but not all of that is due to the vast quantities of generated code. But I think it's also important to say what Kubernetes, what the API Machinery SIG is not. Because there's a lot of confusion out in GitHub issues. We sort near the top of the list of SIGs, and we have the word API in our name. Therefore, clearly, we ought to look at your API review. Actually, no. There's a separate group for doing API reviews, and SIG architecture is probably more interested in your particular API review. Unfortunately, I'm in both groups, so I still might have to look at your API review. But the SIG API Machinery doesn't have to look at your API review. We don't own most controllers. Although Walter, who's not here, is looking into sort of adding more structure to the controller manager. But still, that might mean that we own the framework in which the controllers are running, but we're still not going to own a particular controller. We do consult a lot on controllers. Like there's a bug in the deployment controller where it doesn't properly diff the replica set that is made with its spec, and it can make a lot of replica sets under certain very rare conditions. So last week I spent a lot of time talking to the apps team about how to address that. And we do, yeah, like I mentioned, we don't own the operational characteristics of your cluster. If you give us a support question, we'll probably look at it enough to verify that it's not some systemic problem with our stuff. And there's too many people with clusters out there in the world for us to exhaustively help everybody, unfortunately. We don't own what I'll call downward-facing extension mechanisms. So like CNI, CSI, the other ones, like the runtime interface, the storage interface, the network interface that Kubelet uses to integrate with clusters. In my mind, I have extension mechanisms. I'm spoiling my talk later. I have extension mechanisms split into two categories. There's like outward-facing extension mechanisms that are about policy and adding additional features to a Kubernetes cluster. And then there's downward-facing extension mechanisms, which are about Kubernetes providing its own features despite whatever hardware or cloud environment it happens to be running in. So many of those we don't own. Yeah, so that's more or less what I'm going to say in the API Machinery update, which none of you need to go to now. Other topics?
You mentioned about the generation of informer. You generate an informer for a customer versus today you have to pass the generator, the API group version. So this is going to hardwire everywhere the API group and the version. You plan to extend the generator to take the API group and the version dynamically, for example.
And then in which sense, like
when you start, for example, then when you start the controller, you have to give the informer.
To inform us, this can work today.
This can work today.
I mean, you can generate from two versions, but not dynamic.
But it's basically not give dynamically to the controller the group, for example.
I'm still trying to understand the question. Are you asking at generation time?
At generation time, you pass them, for example, my group / my version.
Yeah.
And then that is going to be hardwired in, for example, in the init of the.
Yeah.
But let's imagine, for example, that I want to write a generic controller that is going to control an API that are resources that is in another
Yeah, so
group, another
there's some tension here between dynamic and statically compiled things. So the informer generator is a way of generating a type safe informer that takes a specific type, and you don't have to do any like typecast or anything. You just get the type back. We have other, so the Kubernetes API system is kind of unique in that we have a common metadata format that all of our objects support. So that means it makes sense to consume objects that you don't know the concrete details of, but you do understand the metadata enough. So like our garbage controller understands the metadata enough to know the relationship between objects, and it can clean up objects when their dependents have vanished. So in fact, our garbage collector has code that generically acts on this. Yeah, so it's a good thing to look at there. Yeah, generally like either you know statically at compile time what objects you want to operate on, or you don't. So if you know what objects you want to operate on, you can run the informer generator, the client generator, and you get static type safe code. If you don't know what set of objects you want to run on, then we've got a set of tools for doing that. There's a dynamic client. There's the stuff that the garbage collector uses, which is probably not sufficiently library. Which we should probably put this in the library.
Isn't the underlying like shared index informer?
Yeah, so the informer gen is actually a layer on top of an untyped library. So yeah, so you can look at the thing that it makes directly. The shared informer business is shared in the sense that it lets multiple controllers running in the same process share a single copy of the objects that they're watching. So it's for memory efficiency. I had someone want it to be something else recently, which was a multiple processes running different queries on the same set of objects to like sort of combine the query, but it doesn't do that.
Is there any thoughts to like adding actual like more like if you start having lots of objects and these things, there's a lot of like looping when you're doing like selectors and stuff like that, add any sort of additional like actual indexing of the labels and so forth?
Yeah, it's a good question. Like how efficient are our queries? Do we index anything anywhere? The answer, generally speaking, is no.
I mean, it looks like it was built for that at some point.
The namespace indexer is
Yeah.
stuck in there.
Yeah, so the informer stuff does have it does client-side indexing, and you can do arbitrary indexing. Depending on what you're doing, that can be massively inefficient for the system. Like if you download hundreds of thousands of pods to find like 3 of them, that's not great. We would like the server to do that for you. Unfortunately, for better or for worse, it's not super easy. It wasn't possible with etcd2 to keep like atomic indexes up to date. It is possible with etcd3, and so I hope to start in the, I don't know, I won't give a time frame. I hope to start keeping a couple things indexed. I think it should be an O1 operation to look up an object by UID. Right now it's an ON operation, which is not good. Yes, so all of our selectors are linear in the number of objects in the namespace of that particular kind, because there's no index. Selectors and labels are such that you could index the various labels separately and combine them into an efficient query. Probably like log in the number of labels or something like that.
Question.
Yeah.
I'm not quite sure why you're conditioning this like XP. Couldn't each API server just get its memory derived index?
Yeah, that's a great question. Like, why do we want etcd to keep the index? And the answer is, well, let me just note that API server is an HA system. So there's multiple API servers that are hopefully all serving the same sort of data.
More or less synchronous.
Yeah.
It's maybe synchronous because they're ready.
So we depend on etcd to provide the to do the heavy lifting there with Raft. In HA systems, you need to turn on forum read so that all of your API servers will, even on reads, give you the same thing. That makes it tricky to defeat indexes in an API server. Where you want, like, if you want to, because you want to do a query on an index, but you want to do the query such that the result at a particular resource version is returned the same among every API server. So I don't think it's impossible, but it's definitely not simple. And so sort of the reason that I haven't wanted to, I mean, we actually do some caching in API server, because we basically cache all the watches. We watch everything in API server and redistribute that in watches so that a client-side watch does not result in a watch to etcd. We did that for a while. But I don't want to go down the road to writing a database software. I don't want to go down that road too far. If I can avoid it, I don't think that that is our competitive advantage. So yeah, this is something we need to think about. And I also don't think we want to support arbitrary queries against API objects. We don't necessarily want to make them efficient. Kind of want to look at what our system does and make sure that the things that do need to happen frequently are efficient. And I think that will be like less development work and less maintenance burden than making a generalized efficient query system.
Yes, okay, well, now I'm down to the point.
I think also from a social
I
perspective.
should, mention why I'm here.
Yeah.
So I've been building distributed systems for lots of years, and I'm a big fan of what in this community we call level-based rather than edge-based management. And so the Kube API stuff this group is responsible for is kind of just a nice general purpose, but looks like a nice general purpose platform for building distributed systems.
Yeah.
So I embarked on an exercise of doing that. And we corresponded in email a little bit. I'm trying to find out how efficient it's going to be.
Yeah. That said, if I have somebody who's pretty interested in making that generally efficient, let's talk. I'm not like super opposed. It's probably not where I can spend my resources, but yeah, there is a lot of demand for running Kubernetes style APIs independently from clusters. So I think
clusters, but clusters that are doing other things, additional things.
Yeah. So I think this is sort of a cached opinion from like 6 months or a year ago. So maybe it's time to revisit and think about if we should do something more. Yeah.
Oh, you had a different.
I was in terms of Kubernetes itself, like it sounds like his particular use case is a little different, but in terms of Kubernetes project itself, I think there's generally like Kubernetes is becoming such a big consumer for XDB that like if something's like not fast in XDB, like a sufficient pressure can be put on the project to actually fix that.
Yeah, I will say that like my team has hired one person and we're hiring another to actually work on etcd because it's important to us.
Right.
So yeah.
So I'm interested in how do all these changes and all these like planned new features reflect on what the clients have to pay for, because the more people etcd is somebody who builds get hired. How much leeway is there to add new features without that?
Are you worried about like resource usage in a cluster?
Resource performance. How does adding new features, adding new indices, basically extra work that today isn't there, affect the bottom line?
Yeah.
Is it even register?
Yeah. Are you thinking more like runtime costs or development costs?
I'm thinking of runtime.
Yeah, runtime costs.
Those are not amortized.
Yeah. So yeah, we probably spent all day on that topic. The question is like runtime costs of new features, who pays for it, and how do we balance that? I think the project has not been super great on this score so far, and I think we're going to have to think about it. There's when we're talking about runtime costs, there's two principal components to that. One is what do you pay on every node? What's the node agent overhead? Because that is multiplied by the number of nodes in your system and becomes a very large number. And the other number is what do you pay for your control plane? You've only got one control plane, so you can afford like a few % of your cluster size for the control plane, and that's not a terrible deal. Unless you're on a very small cluster, in which case a few % makes it impossible to run. A few % of one node leaves you less than one core for your user workload. So I will say we have a number of tunable flags on API server which control how big its caches are. And I think you can probably turn off some of the caches completely. Yeah. So yeah, this is something I think SIG Scalability has set out some like targets for how many nodes and how many pods you support with how many resources. So yeah, I think it's still kind of a thing that we could do better at is measuring, defining limits and defining a budget, basically a resource budget, and like a stock Kubernetes cluster has to fit inside this resource budget. And if you have a smaller one, maybe you can turn off caches or something. Features.
So that's assuming that you can actually get API server flags.
Yeah, that's yet another great point. Is API server has a lot of flags, and it's basically highly privileged to touch them.
Yes.
So I would like to see us in the next year move towards getting away from those flags and towards, I mean, ideally dynamic configuration, like what we've done with the webhooks, where there's like API objects in the system that track the configuration for the webhook. And this means you can put like RBAC permissions on them and decide which of your users can add additional addition webhooks. I think for some flags, that model makes sense. For some flags, we probably want to start reading them from a file and check it with a config map. And I think there's probably a couple flags that maybe should stay as flags. But like you should count those on one hand.
You got to think about which ones would induce restarting, or you don't want to accommodate them changing while you're running. And so if you observe a change in the config map, let's say.
Yeah, I'm thinking of flags like the one that tells you where to find the config map.
But things like feature gates would be nice to not have to like set those in like 15 different places when you want to turn it on for like one thing.
Yeah, feature gates are an interesting animal because really you want your feature gates to be synchronized across all of your API servers and the controllers, and sometimes the kubelet too. Yeah, so that's probably a candidate for building into an API object that everybody across the cluster can pay attention to. And you probably need a like two-phase thing where you like propose a feature set, you wait for everybody to acknowledge it, and then you actually turn it on. Just because it's a distributed system, and you don't want some components to think of features on when others don't. So, yeah, good points.
Is there like documentation anywhere in terms of like when you're using pieces of the API machinery, kind of without digging through code, sometimes it's hard to understand like. And I think it's also complex because looking at existing controllers and things like that and how they implement it, it's like it's a history lesson and understanding like the linearity of that history lesson. Like you see one thing using this mechanism, other thing using something else. So you just kind of like figure you look at different people who are committing and you're like, oh, I'll follow their mental model.
Yeah, I think there's this like. I don't want to document the current state because I want to change like a dozen things, but turns out we're going to live in the current state for quite a while, so we need to do a better job of documenting. Like even if we don't like the documents we have to write, which is definitely if I were to do this over again, I would do a few things differently, but it is what it is, and a lot of people are using it, so we owe it to them to provide better documents.
We have to send a photo of them to check it out. Right? So just as blueprints.
Yeah,
answer their question.
But the sample controller, for example, uses the dynamic or it doesn't actually do any of the code gen or anything like that. It does. Yeah, at least when I was looking at it, we removed most of the CLE term. The dynamic line examples was
Yeah, we'd love help like making this easy. Like as you do things, and like I used to tell people like let us know what doesn't work and we'll try and make it better. But even better than that is if you can suggest changes to the documentation. Yeah.
Is there a documentation to create a customer resource definition plan? If the customer resource definition is worth it.
Yeah, to graduate. Yeah, a CRD to a full-fledged API server. I don't think we've written anything like that.
not even to its easy storage. Nobody's talking about that.
Storage, yeah.
Interesting question. Like if you build something and then eventually it gets adopted.
Yeah, we probably need a storage migration mechanism. We'll probably have to build something. Yeah, that's great. I don't know how much time do we have left?
This is like long. It's until 12:30.
Oh,
but there are like other sessions that run over top of this. So like if you wanted to go to other sessions, like you need to pay attention to the time.
Yeah.
And leave. I think there's another one starting in like 2 minutes. So if you are planning on going to another session, you need to pay attention to the time. Yeah. Yeah. So this is like one of the things that we've talked about a lot, I think, particularly recently with regard to applying Go, these type of things, how to like document this properly. And, like my own view is that there's like how to document the API itself, and then there is the like how to like, document the right types of architectures and the right types of ways of controls for building things like controllers and whatnot. So like there are, you know, like the sample controller is great, but like it also only has one controller in the process, right? So you might have like a process that you're writing, like an operator or whatnot, that has multiple controllers that run inside the same process. And, you know, it's like, oh, okay, like only at that point do you actually really understand like what shared informers are and why they're called shared informers. And, you know, in terms of like, you know, you're making sure that you're actually passing one informer instance to all of your controllers and then watching from that. And then also the type of pattern that a lot of controllers take where like they, you know, they do watches on the API and then they like add a key to a work queue and then process the process changes to objects in the work queue synchronously for a particular object. So you don't have like parallel changes to a single object for a particular type. So these type of architectural things like aren't obvious unless you're like actually reading the source code for Kubernetes. And then on top of reading the source code, being able to like extract out the meaning of the like why the heck are they doing it this way and why are all these like crazy things in Go that
I think once you figure it out, like it's like awesome, like all the rate limiting queues
right,
and all that kind of stuff. But like, and then I think that on top of that, like if you look at it, I mean, having multiple controllers in a single process, it was like, hey, we need to do this, and it was basically like look at what's going on in the, you know, the main controller and like try to copy something that's not necessarily as complex as that. Cool, and then things like the queues and stuff like that. I think that makes so much sense once you get into it.
Right.
And but then when you're building new controllers, you're also creating lots of boilerplate, which, you know, kind of wrap it up in some.
It's also like, because like, I mean, you're using a work queue, but like the work queue is also like kind of a little bit unique in the sense that it enforces the fact that you have a unique key inside of the work queue. Like you don't add a single key like multiple times. So that's like, and why that it's doing that is like, you know, not like, totally obvious sometimes.
Yeah. Fun fact, I was told that after I wrote the work queue, I was told that there's actually some Google internal code that does the exact same thing and has the exact same name. So.
Well, I mean, yeah. What are you going to name something like that?
Yeah.
Besides work queue.
Yeah.
But yeah, yeah, like not totally obvious, and there's a definite pattern that like pretty much all of the controllers are taking in terms of like how they're built, besides like the prime controller.
I think there's even a document from Jaw that maybe about controllers.
Really?
Best practice. And the big problem is how to find those things, right? There's proposals, whatever.
Yeah, I think
Is there a place where these questions are being asked and obviously answered by you guys, that other people need to Kubernetes?
There's documentation in community controllers.
Yeah, yeah.
There's a control documentation. And there's another one, chart, the controller.
That was helpful, like finding lots of examples. I mean, it's kind of like when you're making a recipe, you go out and you're like,
I think
15 different recipes.
I think what people are doing today is they're reading other people, like, you know, the original people read the source code for Kubernetes and they figured out how to do it, and then they wrote their own in that kind of model, and then people saw that, and then they started making their own, and so you have this like kind of telephone game of like, you know, like 3 projects or 4 projects down the line, and then people start like making the mistakes that you shouldn't be making, and then you kind of get into this problem where like nobody really along the line knew what the heck they were doing. They were just like kind of copying the model that other people were doing.
Yeah, yeah. It's interesting to hear what people want documented, because I didn't realize that that property of the work queue, like why would you want that property? It should probably be documented.
Right. I mean, like just the architecture of like a controller, like this is what you do. These are why shared informers exist. Yeah. This is like, you know, this is why work queues exist. Like, you know, every once in a while you see people that write controllers where they do like a lot of logic like in the hooks for the watches, and you're like, no, please don't do that, because that will run in parallel with other things, and like so like just making sure that like folks avoid those pitfalls and that kind of create like sound architectures when they're building these things. And like I also often see the problem of like people will write everything in one controller, and then like they will they basically do a sync loop that like goes and does everything, you know, even though they're watching one object and then they're creating and monitoring like maybe several other ones also. So like maybe they have one CRD that creates 5 other types of Kubernetes objects, and then whenever one of these changes, they sync the entire CRD again, which then syncs all of these, which is not always the ideal thing to do, partly because like people will do sync loops where like all the logic is sequential, and they'll do things like change things in the middle of it, and then later on in the loop they'll like, you know, something else will happen, like they'll do something else, and that's contingent on the fact that what the state of a previous object that they may or may not have changed.
Yeah. So what's the better approach?
So the better approach would be to like build things in a more modular way, such that it can be run in parallel. Like you can have multiple controllers that run in parallel.
Looking at the same top level like CRD version.
So for example, you know, maybe watching a single CRD, but like you have multiple controllers that watch the same CRD, and then you know, write out the individual objects that you care about, and then because you're doing that, like, I mean, there are other pitfalls with doing that, but like from a
You could also run multiple work queues.
right, you can also like, well, each one of those I assume is a different controller running a different work queue, but from a performance point of view, they're all using the same informer and the same like shared informer. So like you're basically doing one watch on the CRD, but it's just calling the hooks in each controller and then doing the stuff that can happen in parallel. And then each one of those is fairly simple in what it actually does. It just like says, okay, if something changed in my CRD, I look at this field and I write out this object.
Yeah, the more sources you have for your controller, the harder it is to write.
Right. I mean, you do have a lot of boilerplate in that case, though. But
I like the endpoints controller as like an example of the sort of minimal controller. It watches pods and it watches services and it writes endpoints.
What was that?
The endpoints controller?
Yeah.
It basically just does a join. You know, finds what pod. So anytime a pod changes, it dirties the services that match. Anytime a service changes, it also dirties it, and then it just writes it out. So that's yeah. I don't know how much has changed since I wrote it, but that's the one that I usually tell people to go look at. And there's also like it gets harder when you're dealing with an object that is in a different API system, like you're
like a cloud API.
Yeah, like starting and stopping load balancers. There might not be a watch. Might not be a convenient watch to notice changes in the external system.
Yeah, we have things like that. It gets funky when you have things that you pull.
Yeah.
We kind of like for our use case, we are like watching things in LDAP, right, and then producing namespaces based on group membership. And for that, we kind of offloaded that into a separate like little. I don't know. It's not really. I don't know. You call it a controller, but it just sits there and pulls LDAP and then creates a config map, and then the controller only looks at the config map, so that the controller itself still stays kind of native to it, and the config map just has like serialized like CRD specs.
Interesting.
And so you can just like, and you know,
another way you can sort of do that is there's a resync parameter. Like if you just want to periodically pull things, you can set that to something other than 0.
Use that. But that actually, I think, is one of the things I was going to mention in terms of like pitfalls that I've seen engineers on the team fall into, where they're like, oh, I need to have a loop that runs and like rescans periodically, or you know, any sort of looping that's happening in the controller that's not driven by the event lifecycle in the work queue, and that resyncing is like glorious.
Right. Yeah, like cool. That's one of the things that the Informer is like totally necessary for, is that like it does watches, but then like periodically does full resyncs. Yeah, and like that will greatly simplify the code that you write.
One other thing that would be really nice is like collecting all of the objects that you created. So let's say you create like a bunch of pods and a deployment and and then you come back into your sync loop and you're like, okay, the first thing I need to do is go gather up all the things that I might have created and do the controller out, all that.
Yeah. So
it'd be like that.
So there's some stuff I want to do. So, do you know about the garbage collector and how that works?
Yes.
Okay.
Are you setting that took a lot of code out of it.
Yeah, that was the idea. Is like the garbage collector should handle basically the teardown half of your controller system.
Like 5%.
So one of the things that I'm thinking of trying to get someone to do in the next year is a introspection API. So you can ask, because the garbage collector has a graph of basically every object in the system and what its parent is. It would be awesome if you could query that and it just gives you back the names and stuff, or UIDs or namespaces, whatever. So that's something I think.
Yeah, that would be helpful, because there's lots of code that we have now that's like, okay, go look at the lister for this type, for the namespace that we're, the top level CRD object is in. Go collect all of those, and then literally just scan that list for looking for control. Like it's not something that like would be. I mean, obviously it's in the garbage collector, but yeah, that kind of for loop constantly is.
Although from your description, I'm a little worried that maybe you have an idempotency problem. Like if you make an object and then you have to go query the system to find out what the name is of the thing that you made, it's easier for code like that to make 2 objects than code that produces a deterministic name, and then you can figure out what it would have made without querying the system at all.
Yeah.
So
that's like unfortunately one of the things that I do with mine is like some of my objects are created with generated ones on the API side, and some of them are generated with deterministic names that I created.
Right.
Because
we always try to use generated names because that and then not store the name in any place, right? Because then when someone like deletes something and pushes, like all the things we're pushing in are like ephemeral things. If you push it in, it does something for a period of time, and the object will be like in a done state.
Yeah, and you know your system more than I do, obviously.
Yeah, no, we had started the other way, but then what was happening is like if you have deterministic names, you could get like cruft that would get left in the system that sometimes like a pod will take longer to terminate or something like that, and someone would push the object back in again. I mean, obviously you can clean up a lot of that stuff.
Yep, you do have with deterministic names. It tends to be a little bit annoying because you have to deal with like collisions.
Yeah, collisions are always.
Yeah, like that's one of the things. Like with, I think things like the deployment controller and stuff have like in their status have like collision count, which is actually included in the hash that it creates, that it uses to create the an input to the hash that it uses to create the names for its replica sets.
Yeah, I wonder if we can provide an additional idempotent saving mechanism. Because right now we use the name for that.
But a lot of the controllers don't. Like,
Well, it doesn't matter for a lot of them, but for some of them it does.
like a lot of the like replica set stuff, it's like all just using like controller rep, and it's like trying to pick up orphan ones and stuff like that as well. So it may be fun. And I guess that's one of the things is that pattern only relevant for things like the replica set controller, or is that a generalized pattern?
Yeah.
That like the deployment controller like does things like adopt replica sets, which you probably on your controller don't need to support, like, and you probably don't want to add that complexity.
No,
like it's very complex how that works. And like I don't know anybody that's ever used it, but apparently it exists and it's important for some reason. Maybe for people.
Maybe it was a backwards compatibility thing at one time.
It may have been, but like don't emulate that, please.
I just made the assumption looking at that code.
It's very complicated.
Using the controller ref was like the appropriate way to determine the things that I own.
Yeah,
versus
it
any
absolutely
sort of
is.
name.
Yeah, it absolutely is, and I think the scheduler does or will soon use that for like as one of its distribution signals.
Okay.
To actually distribute the stuff in the cluster.
Yeah.
But there's like, I guess that's the thing, because there's not really a good clean way other than looping through things to actually like say like, give me all the things that are mine.
Yeah, which is why I want the garbage collector to support that API.
Right.
Or make that API first class and the garbage collector can fill out.
Yeah, like even being able to like index by UID would be super helpful, because otherwise you're.
Yeah, that's also what we mentioned that earlier.
But yeah, the garbage collector, being able to query the garbage collector's DAG is, or even more better.
Yeah, it's actually not necessarily acyclic, but it is a graph.
I
it does,
walked back there.
What's topic OS is working on that on a proposal, I guess.
Okay.
We talked about
for that meaning what?
To get access to this graph. The big question was, what's the use case really is? Do you want something like an external system, like Prometheus for metrics, but now for graphs and all the objects in the system, and you want to have a query engine over that? Or do you want something really real-time in the API server, which is much more complex? And
as soon as we provide something like that, people will build them.
So the other major use case that I'm aware of for people who want this is UIs, which want to display the tree or show users the relationship between the various objects. So like I make a deployment, I want to know like if it's managing these replica sets, managing these pods have these containers, or like I have, and it would be ideal if it went the other way too. Like I have this CRD which has there's this operator implementing it. It connects all the deployments it makes up to the CRD, so you get this nice big tree.
Right.
So do we want the graph database?
The problem also like comes like in that other things are like related, but not related in the sense that they have like a direct relationship, like i.e. selectors.
Yeah.
So like things like what's a member of your service is not like immediately knowable, particularly if like, I mean, for normal objects like deployments and services, like you kind of know because that those have selectors because they're core objects. But if you have like CRDs that use selectors or something like that for these kind of loose couples type of things, like it's not easy to get that out of the API.
And then you also have to worry about skew because the resource versions between different objects are not comparable.
Mm-hmm.
I think even if it was just in like the library that the controller could use, you could just be like, here's a list of informers, or a set of informers for different types, and here's like my top level type now. Like I'm going to give you an object, give me back. It's obviously hard because typing is going to be mayhem.
You can build something
you can sort of build it with
simple utility
with the informers and like add an index to each one. You put an arbitrary function in the index. Yeah, so you can have a function that indexed by controller ref. The scheduler probably does something like that for pods. All right, should we call it a day? Anything else?
I have a question.
Yeah.
I'm working on a project that most of the things needs, I wouldn't say required, installation on C webhook. And so since I was learning about this, I sort of found out that it
is currently quite involved to install one.
Yeah.
Especially for a managed install, you are pretty much out of luck today.
Yeah.
What would you recommend as a good way to resolve that issue?
Help us fix the OSI webhook.
So, okay, so that, that's also an option.
You're not the only person, at least unless you are another person that I know of.
I'm probably that person that you know.
Okay. The OSI webhook has a bunch of problems, like you can't have two, and that is configured statically. You have to have the keys to the API server, and you have to write an obscure kubeconfig file to make it work.
So, yeah, my question is then, what would you like to see changed there?
We could have a long conversation about that. Yeah,
I also want a short conversation about this.
So
there are milestones from between here and the ideal state.
Yeah, so top level goals, I think there definitely needs to be a way to have more than one OSI webhook. I think I'm kind of, you shouldn't have to have command line level access to Kube API server to set that up, I'm pretty sure. But the question in my mind is, should we go to a completely dynamic thing like the admission webhook, or should we move it into like a config map with the rest of where the rest of the flags for API server should go? I haven't really thought that through. Like, who would you cluster really need to have the ability to add OSI webhooks? Like, that's changing the cluster in a pretty fundamental way. So I don't want to build something super complicated for like 3 people.
So I understand the concerns. It's a question of if you want to build an add-on to Kubernetes,
right?
You want to do separate.
Yeah.
And it just so happens that this is where you integrate, then it's a really painful integration.
Yeah. Yeah, and I'm firmly of the opinion that add-ons need to be portable, not just user workloads, because that's another one of my goals for next year is to get the extensibility stuff into performance tests, because I think extensibility features are not useful unless they're universal. If you write an add-on and you can install it in like 8 clusters, that's not useful. You want it to be installable everywhere. Otherwise, why would somebody want to start depending on your add-on? So yeah, I think one of the requirements for this is that we have to provide a way to install a OSI webhook that you can do in pure terms of Kubernetes, the Kubernetes API interface, however that caches out. Like there has to be the possibility of putting in a config map at the very least.
So one problem, for example, that I see with respect to today is that adding a new OSI and any sort of module actually expands the access to the cluster. So allowing dynamic registration is maybe problematic from that point of view, as opposed to mission controllers, where if you add a new one, you can just so even if you make a mistake, it doesn't get worse in terms of all the attack surface.
You can inject every single one now.
Yeah, you could make an admission controller that added that waited for an RBAC rule to come in and then added, changed it into one that gave you permission for everything. It's already pretty. Yeah, I do think though that there's something to what you're saying. Like I think OSI webhooks are a more severe change to your cluster than the admission control webhooks. I don't know, Stefan, you sort of like, it seems a little bit different to me. I also think it'll be less, no, maybe it won't be less common. Do you think it'll be less common? I think it might be less common.
I mean, you won't have 4 or 5 of them. You will not just fix them.
Yeah.
Come to share and install them.
Yeah.
No one-time thing, maybe.
Yeah, probably you have like 1 or maybe 2 OSI webhooks in your cluster because you want to run against, I don't know, your local LDAP and I don't know what else you use to track permissions.
So config map would do what we need.
Yeah. but with admission control webhooks, we do expect, or I expect, like 10 to 30 of them in a cluster in a couple quarters.
Especially since using them for doing any sort of like validation of some resources, it's kind of, you could have hundreds of them.
Yeah, although hopefully those will be scoped to just like one resource each. Yeah.
Well, I can't remember, but the external admission webhook configuration resource, is that a cluster scoped object, or is that it is cluster scoped?
Yeah, it has to be cluster scoped.
Does it have to be?
You can, I believe,
You can restrict the web to namespace, but you still have to register it in custom scope.
But yeah, so like in an instance where maybe you're trying to get multi-tenancy within a namespace and you want to let people configure their own policies with admission. You can't do it today. And
is that a use case that you have?
I just thought it was, well, I think later I'm going to like a multi-tenancy working group and like the part, like the isolation mechanism is the namespace. So
yeah,
there are projects that I've seen where you can fit in a namespace. There are plenty of projects that I've seen that like to have cluster roles, and it seems like if you can fit it in a namespace, that
So my impression is it doesn't sound crazy. It's a very good use case.
Yeah, I think that's something we would want to think carefully about. Just like we need to make sure that, like, if we're going to advertise namespaces as a security boundary for admission webhooks, we need to make sure that we can't do something crazy like change the namespace of the incoming object.
Right. Yeah. I was thinking about like people making like a custom resource that pretty much was a wrapper around this, and then having a controller pick up these custom resources that are namespace scoped, and then going and configuring something which would handle all of the admission.
The good news is you could use the namespace label selector to do that.
Mm-hmm.
Yeah. Are you subscribed to the API Machinery list? Mm-hmm. Yeah. Could you maybe start an email thread there about this? Yeah, I'd like to talk about it more. Yeah.
We did something very similar because we have this concept that for our namespaces that we call which is like a namespace with a whole bunch of predefined RBAC rules. Not necessarily predefined, they're like custom RBAC role bindings that get auto-injected into the namespace. And so we define those in like a separate namespace that they can get put into, and then the controller then goes actually creating the namespaces, all that stuff, so that like we don't have to give anyone kind of cluster scope.
So you created what in a separate namespace?
So we have like this other CRD that kind of represents this higher level conceptual thing that is a namespace plus a bunch of other stuff.
Like a namespace template.
Yeah, almost. Yeah. It's
using it to like create new namespace.
Yeah, OpenShift has like the project resource, and you can submit a request to have the namespace created for you, basically. I don't understand it in detail.
Just the same thing. But it was like that's how we kind of like got around like having to have like cluster scope kind of permissions.
Cool. Thanks everyone for coming. I'm super hungry. I don't know, maybe one or two. This is a good discussion. Appreciate it.
That's fun.